Hello guys, so today we are here to solve a very popular question that is being asked in many different interviews, and this question is number of islands. If we go through the problem statement, then what we'll find that this problem is about you know this problem is about the islands which is there in the 2D binary grid. Okay, so if you look into this, then it is mentioned that this is a m cross n 2D binary grid. 2D binary grid, and it contains only character 1 and 0. That's why it is being called as binary grid. Okay, and it is 2D because it contains m rows and n columns. Okay, and in this we have to return the number of islands. We have to return the number of islands. What is this island? So in this it is mentioned that an island is surrounded by water. So 0 represents water and 1 represents land. Okay, so if you see here, then this one is land. Okay, this is also land, and this is also land. So see, if these, this and all this, so this whole thing is a land parcel. Okay, so in this problem, as per this problem, this will be considered as one land parcel. So the count of island is one here. So this will also be there, because we have to connect adjacent lands horizontally and vertically. So we have to connect adjacent lands which are either you know horizontally connected or vertically connected. Okay, so in all these scenarios we have to get this, count of islands. Okay, so if you look at this problem, this particular setting, okay, these are one, let's say this is one island, then this is also one, and this is also within that same island. Okay, and this top row is extending towards this. Okay, so you can say that in this given grid in example 1 there is only one island, and that's why the output is 1. See here in the second example, this thing is one island. Okay, if you look at this, let me just zoom in a little bit. So if you look at this whole thing is one island. Okay, this four ones is one island, these two ones is another island, and then this diagonal thing. Okay, in between this diagonal thing, this is not horizontally or vertically connected. Okay, so that's why this is another island. So that's why the answer here is 3. 3, why 3? Because this top level thing is one island, this thing is one island, and then this thing is another island. So we have to, the liberty to move is only in four directions: up, down, left, right. Only four direction. Diagonal direction movement is not allowed, and that's why this one is not connected with this one, and this one is not connected with this one, because this one is at at a diagonal with these one, and diagonal connection is not allowed, and that is not being counted as a single island. So had it been one here, then it would have been considered as a part of this island. Had it this cell would have been one, then it would have been considered as a part of this island, but that is not the case. So I hope the problem is clear, and what we need to do now is also clear. Okay, so let's just go through the problem statement. I mean to say, let's try to solve this problem. So this problem is basically, you know first of all, as soon as we hit a land cell, okay, we need to find out how many other connected cells are there which are also land and can be horizontally or vertically reached by this current cell. If you are able to grab all the land cells which can be horizontally or vertically, you know uh, which can be moved which can be reached by moving horizontally or vertically, then all those cells will be part of the same island. So how are we going to mimic this movement? See, the particular cells could be considered as vertices, and the movement in four directions could be, considered as, every edge has four edges. Every vertex has got four edges, unless of course it is not on the, edge of the grid. If it is, inside the, like suppose if it is like this one, then we can move up, we can move down, we can move left, and we can move right. So these four movements are allowed, and with this understanding, okay, we will try to solve this problem. So I'll, I'll show you how we can solve this problem, and we can solve this problem, using two different approaches. First, let me, declare the, these two values. Okay, we will write rows is equal to grid dot length, calls is equal to grid 0 dot length, and then int count is equal to grid dot, no, grid, not grid, it will be 0 only. Okay, for int I is equal to 0, I less than rows like this, and then we will check whether this given cell is land or not. If and only if it is land, which means the cell contains the value character value 1. If and only if it is land, then we will do grid I j, okay, dfs grid ij, and then we will increment the count like this. Okay, return count, and then we'll do private void dfs char array grid int I int j. So first of all, what we'll do, that we will do grid I grid j is equal to 0. So since we have visited this particular cell, we are making it as 0. Okay, so after we have declared it as, that this has been visited and we need not come to this cell again, what we will do, that we will now look at the four diagonal, you know four horizontal and vertical directions, up, down, left, right. How are we going to do that? So for that, what we'll do, that we'll consider I minus 1. So I minus 1 should be greater than equal to 0. It should be greater than equal to the 0th row. Okay, and grid of I minus 1 j should be equal to 1. Okay, like this. If it is like this, then we are allowed to go to that cell by moving the dfs to dfs I minus 1 and then j. If I plus 1 is less than grid dot, so already we have this rows, so we'll use this rows. Okay, rows and grid of I plus 1 j is equal to 1. In that case, what we'll do, that we'll do dfs grid I plus 1 j if j minus 1 less than calls and grid I j minus 1 is equal to 1. J minus 1 is greater than equal to 0, not calls 0. Okay, and character 1. Grid I j minus 1 like this, and then what we will do, if j plus 1 is less than equal to calls, and grid I j plus 1 is equal to 1, then in that case also it will be grid I j plus 1. So this is the DFS movement, and to check whether this is running fine or not, we can submit this. So but let me reiterate what we are doing here. So in this, what we are doing, that we have declared two variables which are storing the you know boundaries of the uh, grid, how many number of rows are there and how many columns are there, and then we are initializing this count value, and we are iterating through the cells, grid cells, and we are counting you know how many times we are kick starting the DFS movement. So because we are kick starting the DFS only when we are encountering a land cell, and once we are encountering the land cell, what we are doing, that we are doing a traversal to all the horizontally and vertically connected adjacent land cells, so that all these adjacent cells um, could be counted under the single island. And after traversing, we are turning that land cell which is having character 1, after having visited it, we are making it the making the character 1 to be changed into character 0. Why we are doing it? We are doing it because we want that you know change of value to be such that, so that we don't um, you know get back, again go back to the same cell. If you do that, then we'll be moving in cycles, and it will be defeating our purpose, and this DFS recursion is not going to come to an end. So to avoid this cyclic movement, we are making it changing the character value from 1 to character value 0. So I hope with this it is clear, and this movement is just going up, going down, going left, going right. So like that we are doing this movement in the different ifs. And let me just run this. Hmm. Where is this array index? Less than, yeah, less than, it should be less than. Perfect. Let me just submit this. So fine, this is one way to solve this problem. Okay, are there any other ways also to solve this problem? So actually there is one more way to solve this problem, and that is, here we have employed DFS, depth first search, but we could also have employed BFS. So if we employ BFS to solve this problem, so for BFS what we need, that we need to have a deck. Okay, and deck should be uh, at any time and at any moment of time, the deck should be containing the adjacent cells. So a cell is nothing but a grouping of it's a class which abstracts the row and column. So for that we have to declare one cell. So how can we do that? So we'll be doing it using by declaring a class called cell. Okay, and this cell will be int row, int row, int call, and then a cell constructor will be declared, int row, int call, okay, and this dot row is equal to row, this dot call is equal to call, okay, okay, okay. So this deck is going to contain that cell, and let's call it as deck, and it will be new array deck, okay, and deck dot offer, it will be off, we are going to offer one new shell to it, okay, so it will be I and J, okay, and after offering it, what we are going to do, we are marking that particular thing as visited, and then what we'll do that we'll take while the deck is empty. If it is not empty, so it is not empty, it means it contains some of the cells, okay, so when it contains some of the cells, what we can do, we can always get the cell at the front. So to get the cell at the front, we have to do this poll, okay, so once we have done this poll, it will get the cell at the front of the deck, okay, and we will use this cell to you know do a movement. So to do the movement, what kind of movement we need to do, we need to move in the four directions. To move in the four directions, what we need to have, we need to have a directions two-dimensional array. So directions two-dimensional array is equal to new, we can do it like this, so these are the four directions that according to the problem we are allowed to traverse. According to the problem, we are allowed to move across on the given cell. Of course, that movement has to be within the boundary of the grid, okay, so like this it is there. And then for int array dir, okay, so int new row is equal to cell dot row plus dir 0, int new call is equal to cell dot call plus dir 1. So this is there, and then we can we can put a check if within bounds, okay, and what we will do here, that we will pass the new row and new call, okay, and then also we need to check is land, okay, so what we are going to do, we'll pass the grid new row and the new call, okay, like this we will pass. And if it is land, then what we will do, that we will take the deck and then again offer the new cell to the deck, and to offer that we have to create one cell. The cell will be having the row as new row and the call as new call, okay, like this. And then what we will do, you know on the grid we have to mark that new row and new call is equal to like this, and this, okay, so this is, we don't require. What we will do, that we will get rid of this, So once this thing is there, we can let this thing, and then we would need to complete this boolean within bounds, int new row, and it's better we use smaller names, so that it is easy for us to write the code. So we will do 0 0 is greater than equal to I, and I is less than rows is there at the top. Yes, we have declared the rows. Yes, here we are declaring, so it's there. And 0 j, and j is less than calls, so we are returning this. And then private boolean is land char c, return c is equal to 1, like this. So if you have done this, then I don't think we need to do anything else. We need to just run this and check whether it is giving the correct answer or not. So let's just go through what we are doing in this. So first of all, we are declaring the rows and the columns and the count, and then we are going through the each of the cells. And as soon as we encounter a land cell, what we are doing, we are kickstarting a BFS traversal for all the adjacent cells of the given land cell. The adjacent cells are those cells which are located at a horizontal and vertical, uh, at a horizontal or vertical, you know uh, cell from the current cell, at a horizontal and vertical direction from the current cell, up, down, left, right, these four directions. And we are kickstarting the BFS. After kickstarting the BFS, we are able to gather all the components, all the connected components of that particular land cell. And once we are reaching it, we are declaring it as water cell. Why we are declaring it as water cell? This is our way to mark it as a visited. So we are doing it 2 times. Okay, here also it should be water cells. Okay, so I think we are done with this. Okay, yeah, I think we are done with this. Let me just run this. It should run perfectly. Oh, spelling mistake is there. Perfect. So you can see that BFS is running little slowly. Why it is running slowly? Because see, we are using a queue here, and this queue is storing all the adjacent cells, and then it is uh, polling it, getting the cell at the front, and then again it is getting to the adjacent cells. So it is moving in a very conservative way, and it is going shallow first, just one level, then second level, all those different level by level it is moving. And that's why it is this movement is very shallow movement, unlike the depth first search, where it is going, penetrating deep, striking deep. Okay, so that's why this BFS is little slow, but the outcome is same. And you would find that whenever you are using DFS, the DFS is obviously definitely at times it is much faster than BFS, and in those times you must be using you know uh, DFS, when DFS BFS both can accomplish the job. So with this, I'm thanking you. Thanks a lot. Happy coding.